With the green phosphor suspension, an accurate amount is poured into the faceplate. The spinning motion distributes the suspension evenly over the entire surface of the faceplate. It is dried by infrared radiation. Because photosensitive materials are involved, this area too is lit by sodium lamps. Great care is taken to exclude dust, and an air conditioning system maintains the correct temperature and humidity. A numbered shadow mask is inserted in the faceplate with its green phosphor layer. The faceplate is marked with the same number, and from now on this faceplate and this mask are permanently paired. The green phosphor layer is exposed to ultraviolet light, using the shadow mask as a negative. In this way, the pattern of holes in the mask is projected onto the phosphor layer. The position of the light source is critical. The light must strike the phosphor at exactly the same points as will the corresponding electron beam. The action of the light hardens the phosphor so that the exposed dots adhere firmly to the faceplate. After the mask has been removed from the faceplate, the unexposed phosphor is washed off. The faceplate now carries a regular pattern of green phosphor dots. The blue phosphor suspension is poured into the faceplate. The complete process is repeated, but now the light source is positioned at the point where the blue gun will be in the finished tube. For the red phosphor, the light is emitted from the red gun position. The completed screen now consists of a regular pattern of nearly 1.5 million phosphor dots. After each stage of the process, the dots are checked for shape and size with a microscope. The phosphor screen is now backed by a very thin layer of aluminium. This acts as a mirror and ensures that all the light produced by the phosphors is radiated forwards. The shadow mask is now permanently secured to the faceplate. Spring contacts are welded onto the shadow mask. These will later connect the mask to the electrical circuit of the receiver. The faceplate is now ready for fixing to the cone. To the edge of the cone, a glass bonding paste is applied. The faceplate is positioned with extreme accuracy by means of a special jig. The assembly passes into an oven where faceplate and cone are hermetically joined. The tube envelope is now ready for the gun assembly to be sealed in. This consists of 3 electron guns, 1 for each color. The guns are assembled simultaneously in a special jig to ensure that their electron beams will intersect precisely in the holes in the mask. Each gun assembly consists of more than 70 components. Such is the standard of accuracy required that assembly tolerances are measured in microns. The gun assembly. Inspection has taken place at every stage of its manufacture to ensure that it meets the exacting standards of reliability and performance required. Now the gun assembly is carefully located and sealed in the neck of the tube. The tube is evacuated and sealed off. On the way to the next process, the cathodes of the 3 guns are activated. Finally, a metal rim band is cemented around the faceplate to reinforce the tube. This construction does away with the need for a safety shield. The quality of the direct vision picture is thus considerably improved. The color television picture tube is now complete. Before leaving the factory, however, it is thoroughly tested. The measurements made of cut-off voltage, emission, white field uniformity, vacuum, brightness, convergence, and beam landing are only some of the many checks carried out. The tubes are sent to the packing department. From there, they are dispatched to customers in many parts of the world. Color adds a new dimension to the world of television. And the key component of any color television receiver is its picture tube.